I have discussed one of the important topic, that is binary search. So you have created it, then how do we read the value and how you will print? What is LSD, sir? That is the name of the list that I have given for all of you. If I have the list inside the list, I will call that as a nested list. Okay, suppose if I want to access this element, what is that index that I have to write? So L1 of 0, 1. Hello everyone, I welcome all of you to the third session on data structure 1, linear list. So what is that I have discussed in previous sessions? So guys, before I start today's session, for all of you, I would like to give you a small recap that what I have discussed in the previous sessions. So without wasting much of your time, let's start the recap for all of you. Right? So what is that I have discussed? So I have discussed a different types of data types that we have. Along with that, I have discussed different data structures. So what is the different data structure that I have? So I have the first one that I have is linear list array. So guys, linear list array, that is the first thing that I started with. Then after that, what is the second one I have? So I have queues. How exactly we insert the data to this queue, how exactly we delete the data from this queue, what is the principal operations that we should remember with respect to queue is what I have discussed in the previous session, right? So along with this queue, I have discussed one more thing, that is stacks. So what is the next one that I have discussed? I have discussed about stacks. So how do we insert the element, how do we delete the element from the stack, and what is the principle it follows is what I have discussed with respect to stack. Then what is the next one that I have? Can you all recollect? Yes, of course. I have something called linked list. I have something called linked list. So please remember node when it comes to linked list. So what is that you will remember? Node. So please remember CD stand. This is how we insert the data into this stack. Okay, so please remember rear end and front end. Always deletion will happen at the front end. Insertion will happen at the rear end. This is what you need to remember when it comes to the concept of queue. And also we have different types of queues. That is what we have discussed in the previous session. When it comes to array, so please remember homogeneous. Okay, homogeneous values you can insert into this linear list, and sequentially you can access the data is what I have discussed. Along with that, what else I have discussed? I have discussed one of the important topic, that is binary search. What is that? Binary search. So please remember binary search in the sense you will calculate the mid value. You will calculate the mid value. How do you calculate the mid value? So please remember lower bound plus upper bound divided by 2. This is the formula that you should remember when it comes to the concept of binary search. Along with that, I have also discussed how do we insert an element inside the array. So please remember that also. That is the last concept that I have discussed. That is the last concept that I have discussed in the previous session. So guys, how do you insert an element into this array? So please observe, suppose if I want to insert any element to this, okay, so what is that I will check? My item is 35. So this item should be greater than whatever item that I have here. Suppose if I want to insert here, okay, so this should be greater than this element, and whatever the item that I have here, so that should be greater than this. For example, I should have 30 and I should have 40. So 30 is lesser than 35 and 40 is greater than 35. So I should find a perfect place. Once I got the perfect place, I should shift all the elements and I should make room for this element. So this is what you have to remember with respect to inserting an element into the linear list, right? So guys, this is what I have discussed in the previous sessions. Suppose if you have missed out watching the session, please go back and check out what is that I have done in detail in the previous sessions, right? So without wasting much of your time, guys, let me go to the next topics that you have in this chapter, right? What is that I will be discussing? So I will be discussing, without discussing this, so can you tell what is that concept that we should remember when it comes to the revision parts? Yes, I'll give you an assignment before I move on to the next concepts that I have in this chapter. What is that you should remember? So I have taught you how to insert an element into the linear list. In the same way, if you just reverse the methodology, you will be able to write an algorithm to delete an element from the linear list. I want all of you to check out for that. Okay, so guys, in this concept you should also remember, so this I have taught you with the ascending order in the previous session, but all of you please try how do we perform or how do we write an algorithm for descending order. When we have the elements with the descending order, how do we write an algorithm? That is what I would like to give an assignment for all of you. Please check out that and please try out how to do it, right? So hope you will do that, guys. Moving on to the next one, what is that I will discuss in this topic, right? In this session, I will be discussing something important about list comprehension. What exactly list comprehension is all about. So already Python is helping us to reduce the length of the code, but list comprehension is a wonderful topic that it will reduce little more the number of lines when we are writing the code, right? So I'll be speaking about it. Then we have something called nested or two-dimensional list in Python, which exactly looks like a matrix. Okay, so how do you pronounce it, matrix or matrix, right? So it's up to you, right? I will be discussing about that in detail in this session. And I'll also discuss how do we create 2D list. I will discuss how exactly it looks in this topic, and also how I will discuss how do we create with a program. I'll demonstrate a small program. I'll take up a small program and how do we create two-dimensional list, right? After that, how do we read the values? So you have created it, then how do we read the value and how you will print is what I will be discussing with respect to this topic with the program, right? And also you can access the elements and you can change the elements in the two-dimensional list. That is also I'll be discussing how do we do that with the help of the indexing, how exactly the indexing is working. And also I will discuss how exactly it is stored, and the last one is slicing of two-dimensional list, right? So this is what I will be discussing for all of you in this session. So keep waiting until you get all these topics, right? So let me start with the first one. So guys, please look at this diagram what I have given on the board for all of you. So what is that you have here? Please observe carefully. The session is going to get intense now. So what is that I have given here? So first you have given first, right? So please understand that that is not first. It exactly says about, like, I have LSC, that is the font that I'm trying to use here. So for all of you, right? According to this font, this is LST. What is LST, sir? That is the name of the list that I have given for all of you. What is that? Name of the list. What is that? I have given name of the list and I'm creating empty list. I'm creating empty list. So why are you creating empty list? Please observe, I'm using square brackets. If I use square brackets with no elements, I will be creating the empty list is what you have to understand, right? I have created empty list. So, right, I know about it. So please explain the next thing, sir. Fine. I have the for loop here. I have the for loop. For loop will run from 1 to 5. 5 iterations, is it? So guys, I have 6. 1, 6 is what the range that I have given. So this meaning number of times. What is that I'm executing? So please observe here. I am executing this command this many number of times. Now don't worry about the number of times it executes and don't worry what exactly it is trying to do. I've just taken an example, right? But I have 3 lines. In the first line I have created the list. In the second line I have the for loop. In the third line I'm adding the element to the list using the function called append, right? What is the big issue, big deal with that, sir? Please observe the second thing that I have. Very important part. So in this slide, right? What is that? Please observe here. All these 3 lines are condensed, compressed to one single line without changing the meaning of these 3 lines. So what is that? I have given the name of the list. Yes, I have the name of the list. I have used the square brackets, whatever I have used here. So I have used it, right? So please understand this part. This is for the expression. What is that you wanted to execute? So this is the part where you will give the expressions. What is that you wanted to perform? So here I'm trying to perform I into 2, right? So what is that I'm trying to perform? I into 2. So that value will get added to this particular list. I don't have to use the append function at all, right? So whatever I perform here, so this value will get added to this list automatically without using the append function, right? So guys, so that is what I'm trying to do here. So after that, so I'm using this for loop. So the for loop is working as it is. So this many number of times, so this calculations will be performed. So this type of writing the list is what I will call it as list comprehension. I will call it as list comprehension. So I'm just reducing 3 lines into one single line. So always this first part, whatever I have, so I will be giving what exactly the statements that I wanted to execute. The second part what I have is for the loop. Second part is what I have is for the loop. So guys, so this is how I will be reducing the number of lines when I'm using the list. So this concept is what I will call it as a list comprehension. So why do we have this list comprehension? What is the advantage that I have? Yes, of course I call this also as a shorthand operators. So which is reducing the number of lines. So what is the advantage then? Yes, let's have a look at that. So first one, as we have already discussed, it reduces the code. The length of the code will be reduced. If I use this concept is what you need to remember. What is the next advantage that I have? Faster code processing. What is that? Faster code processing. Please understand that I have given a blank for all of you. So let us understand that list comprehensions are executed faster than their equivalent. Which kind of loops? It is for loop, right? So what is that? For loops for 2 reasons. What is that? Please understand. The first reason will be Python will allocate the list memory. Python will allocate the list memory first. Before it performs any calculations, it will allocate the list memory. So the second one is it also calls the appropriate append function get avoided. You don't have to use this append function here. So you are just trying to avoid that append functions. So that's why code is faster when we compare to the conventional way of writing the list, right? So hope you got the fair idea with respect to the list comprehension, right? Guys, just have to remember whatever the 3 lines code that you have, so you are going to reduce it to one single line. How? So whatever the statement that you wanted to execute with the help of the list function, so that part, right, you will be writing it here. That is the first part you have. This is the place where you will write your expression. The second part, whatever you have here, so this is reserved for the for loop. That place is reserved for loop is what you have to remember, right? So this is how we will be writing the list comprehension. You have to remember this syntax. This is for the expression, this is for the loop, right? So by saying this, moving on to the next concept. What is that I have? Nested or 2-dimensional list in Python. It's very simple, as the concept itself explains. Nested in the sense what exactly the nested is all about. Nested in the sense we have already discussed. We have a if condition. In that we have nested if. In the same way we have the nested list. What exactly the nested list is all about? I have the list inside the list. So that is what I will call it as a nested list in simple words, right? What is that? I have the list. If I have the list inside the list, I will call that as a nested list, right? So how exactly I'll be able to do that, right? So let's have a simple example. Guys, can you all call this as a list? Of course I can call this as a list, sir, because I have the data items in terms of objects and I have the square brackets. The name of the list is LA. The name of the list is LA, right? So what is the second list you have? So LB, so again you have the elements in the LB, which is enclosed with the square brackets, right? So please observe this LC. So I have 1144 LB. What is this LB, sir? So I have the 1144 LB. What exactly LB? Please observe LB is here. I can store the list inside the list. So this is what I will call it as a nested list. This is what I will call it as a nested list. This is the second way of writing the list, right? So please observe this example. I have 11 LA in the sense this one, LC in the sense this one, and 15. Can I store like this, sir? Of course, yes, you can store like this. So this is what I will call it as a nested list. Please understand, this is very, very important, right? So this we can do it, and also we can try something like this. Please observe this. What is the next thing I have? Two-dimensional list. So we discussed nested list, and also we are discussing two-dimensional list. Both are same, right? So we can also write like this. Please observe here. I have list 1, list 2, list 3. Can I write like this, sir? Yes, of course you can write. I have the list inside the list. This is what I will call it as a nested list or two-dimensional list. Suppose if I want to access the elements whatever I have here, how do you access, sir? How do you access? So guys, let's try out how do we access this. For example, if I have the list, I will take it as L, right? So I have 10, 20, 30, 40, right? I have 40. How do we access this? So let's take L of 0. L of 0 in the sense what? I have 10. L of 1. Can you tell me what is that I have in the L of 1? I have 20. Right? I have 20. I'm not supposed to write the square bracket here. Let me just erase it for all of you. How do we write for 30? So L of 2 is equal to 30. So this is how we write the index for the one-dimensional list. Like when we have, how do we write the index for nested list? Let's check out that, right? Right, what is that I have to write here? I have L1 of 0. If I write 0, guys, so this element, if I write 0, in the sense it is this, okay? So guys, if I write 0 of 0, so can you tell me what exactly the element is all about? So this one, okay? Suppose if I want to access this element, what is that index that I have to write? So L1 of 0, 1, right? So this is how you will be writing the index for this. So can you all guess for this? How do you write it? Yes, L1, okay? This is what I will call it as 0. This is 1, this is 2. So I want to access this. What is that you will write? L1 of 1. So if you want to access 3, so you will be writing 0, right? So you have the list, inside the list, always the index of the list starts from 0 is what you have to remember. So hope you got to know how exactly we are writing the index now. Okay, the simple concept that you have to remember, even if it has got the nested list inside the nested list, you can also have the list inside this list. But remember, the concept remains same. The concept remains same. Okay, the first one will give you this, the object index. Then after that, it will go inside. Again, it starts from 0, right? That is a simple concept that you have to remember. Even if you have n number of lists which is nested, you will be able to write the index very easily and comfortably, right? So let's understand this. Two-dimensional list is having all its elements as a list of same shape, 2 dimensions. That is the first important point that you should remember. When it comes to the two-dimensional list, so it should have the number of elements inside the list as same. So that is the first important point that you should remember when it comes to the two-dimensional list. What exactly it means? The number of elements that I have here, so it should have the same number of elements with all the lists whatever I have in the list, whatever I have inside the list. Suppose if I don't have in any one of the list. Suppose I have 3 here, then I will not call that as two-dimensional list. Instead, I will call that as ranked list. So you can observe here, the dimension and the shapes of the list, whatever I have inside the list, is not equal, is what you have to remember, right? So this is the difference that you should remember when it comes to two-dimensional and ranked list, right? So moving on to the next topic that I have, creating two-dimensional list. How do you create two-dimensional lists? So let's have a quick example with the program. So let us understand how exactly we are trying to create. But one thing you need to remember, so first of all, I should have a list. First of all, I should create a list. So inside that, each and every iteration, I should create one list. So please remember, so this is the first step that I will be doing in the first for loop, and then inside for loop will be creating this list. So each inner for loop will help me to create one sub list. Okay, so but outer for loop will create this. So let us understand how exactly we will be creating the list inside the list. Let's have a check how exactly we are writing the program to create the 2D list. So guys, over the first line that I have, this line will create the empty list. This line will create the empty list. So the name of the list is LST. So with the square brackets. So this is the main list that I'm going to create. Then after that, I'm just reading the value from the user, how many number of columns and how many number of rows that I want. So that is the two values which is very, very important for me. Okay, so because inside the loop I will be using this. So this is the first loop, and inside I have one more loop. Okay, how many number of rows I want to create and how many number of columns I want to create is based on the user input. Please understand that. Okay, I will come back to this point again once I'm done with this explanation. Look at the board, everybody. So guys, what is that I have? I have the for loop. So I have used the range function. This function will run r number of times. What is the r value that you have given? So that many number of times, whatever I have this content, so this content will be executed this many number of times. So that's what you need to understand. So fine, what is that I will execute inside this? So let us understand. I have row. So I have row. I am trying to create one more list. That is also, I will call it as empty list. So guys, I'm trying to create one more list inside the list. This is what I will call it as a nested list. So fine, I have created two empty lists. Okay, I have created two empty lists. I'm trying to use this for loop to add the number of elements, whatever I wanted to add to this empty list, whatever I have created. So fine. So I've taken the input from the user again. I'm using append function. Whatever the value that I am taking from the user, I am storing it in a variable called ELEM. So, and I'm appending that values to this row. Fine. So this inside list, whatever I have created, so I have not placed it inside LST. So first I am adding all those elements into ELEM. That elements, whatever I have, I'm just adding into this row. So fine. After that, I will come out of this loop and then I will add so to this LST in the sense this. First, I will create this empty list. Then after that, I will create inside the for loop. So one more empty list. Then I will add the element. Then I will append that to this list. So this will be executed. So the number of times that you have asked to execute. So based on the row values, please observe. So how many number of rows, that is R value you have given. So that many lists, nested list you will be creating. And what is the number of C value that you have given? So that many elements you will be inserting inside this list is what you have to remember. So this is how you will be creating the list inside the list. So moving on to the next one. How do we traverse? It's very simple, guys. So I'll be using the print statement. So this will print it as it is. List is created. Then after that, guys, so I have to print this also, right? So LST is equal to square bracket. So this will print LST is equal to square bracket. Then followed by what it will print? Number of rows, whatever I have. So all those things. So like, that many number of times this for loop will be executed. So guys, please observe here, I have a tab space, then I have one more flower bracket. So tab space, one more flower bracket, then I have space. So what is that? Again, it will go inside. So it will print, it will reach all the values, whatever I have. It will reach all the values, whatever I have. So for example, I have 1, 2, 3. So it will close. Then again, so it will go back, closing flower bracket I have here. So again, one tab space, it will come back. Okay. So again, it will read the next list, whatever I have here. So until it reaches the end, or until it reaches the limit of whatever I have given in the range, it will read all the values, whatever we have inside the list. So this program will help me to traverse through all the elements that I have inside the list. So this is how you need to understand. Moving on to the next concept that I have, accessing or changing the individual elements in the 2D list. Guys, so this is how I will be able to access the individual element that I have in the list. Guys, this is what you need to remember. Fine. So individual elements can be accessed in the 2D list by specifying its index in the square brackets. So we have already discussed this. So what is the next point that we have? Using the same syntax, we can also change the specific value in the 2D list, as the lists are mutable types. Please understand, this is very, very important. So lists are mutable type. Tuples are not, right? So you will give the particular index. So that particular index, you will use assignment operator. So whatever the value that you wanted to store in this specific position, so you will be typing that. So this value will be stored in this particular location. So this is how you will be changing the elements in the 2D list, right? Moving on to the next one, how a two-dimensional list is stored. So guys, please observe this. This is very, very important. I'll just move out of the frame for a second. I want all of you to go through the diagram, what exactly that we have. So especially you should look at the table that I have given at the bottom, right? So TDL, whatever I have given at the end. So please look at that. Hope you have gone through, right? So let's start. What exactly this is all about? How exactly we store the data in the list? Of course, we store the data in terms of string. So let's go back to the previous slide and check. So list stores in the memory exactly like strings. Exactly like strings. Why are they pointing out this point here? So because strings stores the data in a different way, and we have something like integer. So integer is stored in a different way. When it comes to integer, you have just a reference to that particular number. You're not storing any value specifically in the memory. For example, so if I write a is equal to 10, you are not storing 10 in this position. For a, I have allocated some memory, so I am not storing 10 in this memory. For this memory, I am naming a, but I am not storing 10 here. But what are you storing? So you are storing the reference. I have already predefined numbers in Python. I'm just storing the address of 10. I'm just storing the address of 10. So this a contains the reference to this 10. But strings are not like that. List stores the value like how exactly the string stores. String stores as it is. Whatever you write, for example, a is equal to Kaushik. Okay, so what happened to this? I will allocate some memory to this a, so I will write as it is, whatever I have. So this is how the string stores, same way the list also stores the same way, right? Like how exactly the string is storing. That is what you need to remember. But when it comes to the numbers, guys, I have the reference here. I have the reference. So let's understand the last point. So 2D dimensional list stores the reference of its elements list at its index. This is very, very important. I will read out this and this for all of you. Listen to me carefully, because these 2 points are very, very interesting, because I have discussed list stores the data like how exactly it stores in strings, but these 2 points are giving you a different dimension. Listen to me carefully. Each value of individual items of the list are stored somewhere else in the memory. Each value, whatever I have, that is stored somewhere else in the memory. So point number 1. Point number 2, in 2D list stores the reference, not the value. It stores the reference, not the value. Reference of its elements list at its index. At its index. How exactly? Imagine this is a list that I am trying to create. So it contains the reference. It contains the reference. This is what I will call it as a reference. In the first index I have some reference. Second index I have reference. If I track this, what will I get? 20300. So 20300 in the memory location I will get this. So I will go to this 0. So this 0 in this location, what is that I am getting? So this is a pointer to the 3 I am getting. So this is what I have stored in this location, the first index. So I have the reference. I have the reference for 6. Where is the 6? Here. I have the reference for 6. In the second, that is in the index number 2. What is that I have? I have 4. So I have the index for 4. I have the index for 4. So guys, this is one list. I just have the reference inside this list. But I have the numbers already. I have stored the numbers already in the memory. So instead of storing the values, I am just storing the reference. I'm just storing the reference. You just have to understand this in a simple way. I have the list. I have the list. So inside this, I have one more list. Let's imagine I have 2 lists. So I will store the address of this 2 lists. So that is what I have done here. That is what I have done here. Okay, so for this list also I have the index, I have the address. So that is what I will call this. So using this, I will access the main list. So if I use this, I will get the address of this 2 lists. So using this, I will access this list. So I will go to that particular list. So if I use this index, so I will be able to get the reference for all the values, whatever I have stored. That's what you have to remember. And this is how we store the elements inside the list. This is how exactly in Python it stores the integer value also. So guys, by this I have the last topic for the day, that is string slicing. String slicing is also a same concept what we have done in the previous sessions. So it also contains the same syntax, that is start, stop, step. That is what you have to remember. I have some of the examples here. So guys, I have given LST. So I've left out the start option. Okay. So and I've given only the stop option. So till 2 I have. Okay. So if I give like this, what I will be printing? Can you all just guess? So this is my list. How many nested lists I have? 1, 2, and 3, and 4. So 1, 2, 3, and 4. 4 lists inside I have. I have main list. So inside that 4 sub lists is what I have. So I have given the start. It should start from the beginning. That is the meaning. Okay, if I don't mention the value. So I have given 2. So till 2. So guys, the first 2 lists should be printed. So what is that output? So I have first 2 lists will be printed. So this is the output that I have. Right. So one more example I have taken. So 2. It should start from 2. Right. So I have not given the stop. If you don't mention, it should print till the end. So guys, what is that I have printed? So I have started printing from the index 2. Okay, this is 0, 1, 2, and 3. Right? So it has taken from 2. So this is how the string slicing is working in the 2D. By this, I have come to an end of this chapter for all of you. So guys, please listen to me carefully. So what we have discussed. Okay, I have discussed complete chapter. Just go back to the syllabus copy. What is there in your syllabus? That is a revised syllabus. Only take that. I have given you the complete thing because suppose you would have forgotten a lot of things what we have discussed in the class 11. So that is the reason I have discussed the complete thing. So guys, I have discussed what is there, what is not there in one more video, that is reduced syllabus. Please go through that once again and then go through this chapter completely. By saying this, please take care of yourself, take care of your family, share this video, like this video if you have liked it. Thank you very much. Bye bye.